finite geometric series. A geometric series is a sum of terms of a geometric sequence. So we're going to do the finite ones, right? Those are the ones that end. So we're going to talk about how to add the terms of a finite geometric series. So there's two formulas. These ones are identical. It's not like the arithmetic one where there's like two kind of different ones, and you need to kind of pick which one's best. These are identical. I'm more comfortable using this one. That's how most books have it. But again, they're identical. If we look at all the values here, right? U1's the first term. R is a common ratio. We're doing geometrics. That's common ratio. And keep in mind the way you find R is you pick one term and put it over the one before it. So U2 over U1, U3 over U2, etc. Okay, so first example. Find the sum of 2, 6, 18, 54 to the first 12 terms. So we're going to write down the formula. Again, they're identical. This is the one I prefer though. Or should I say the one we're used to. Now, we need to find, let's see, U1. That's the first term. 2, easy enough. And we need to find R. Now remember, R is just you pick a term, put it over the one before it. So 6 over 2 is 3. You can also put 18 over 6, 3. 54 over 18, 3. And then N is 12 terms. So if I want the sum of the first 12 terms, it's going to be 2 over 1 minus 3 to the 12 over 1 minus 3. Now this is straight out calculator. I'm not going to do this by hand. Don't know how to. So we're typing in our calculator. Now to make it easier, I am going to do the fancy fraction button. So I'm going to press alpha y equals, brings up the fraction hotkey, and I'm just typing in the way I see it. So 2, 1 minus 3, you can read my own writing, to the 12th power, closes parenthesis, on the bottom, 1 minus 3, also known as negative 2. And we get this, 531,440. There we go. So that's the first one. Second one, find a formula for Sn, the sum of the first n terms of a series, given this. So we want to find a formula. What does that mean? That means in our general formula here, Sn equals U1, 1 minus r to the n over 1 minus r. We're not going to substitute in for n, right? If we want a formula, we leave n alone. So we're just going to plug in for r and for U1. Well, U1 is 9, and my r, put one term over the one before it, I get negative 1/3. So to find my general formula, this is going to be 9, 1 minus negative 1/3 to the n, all over 1 minus negative 1/3. Now, usually when they want a formula, they don't want it to be this fancy. This like, I shouldn't say fancy. That's not this like unsimplified. They want you to simplify it a little bit. Okay, so keep in mind, I cannot simplify this because, right, you do the exponent before you multiply, so you have to leave this alone. But down here, you can simplify. This is 1 plus 1/3, common denominator. I get, what is that? 3 over 3 plus 1 over 3, which is 4/3. We'll deal with that in a second also. So 1 minus, again, this I cannot change. This has to stay like that. On the bottom, I have 4/3. Now we're going to talk about, again, fraction over fraction is not usually the best. We'll talk about how to simplify this. The general rule is the thing on the bottom here gets moved up to the top. It's because if you want to get rid of it, you multiply both top and bottom by 3 over 3. So really the shortcut is just move that bottom to the top. So I get 3 times 9 is 27. 1 minus negative 1/3, again, I cannot change that, all over 4. And that is our formula that they want, right? So this is, well, this is correct. A little nicer will be this. That's just like simplification. Next one, a geometric sequence has first term 5 and common ratio 2. The sum of the first n terms of the sequence is 635, find n. So we have our first term is U1 is 5 and our common ratio is 2. And the sum of the first n terms, so S of n equals 635. It wants to find out what n is. So let's write down our formula. S of n equals U1, 1 minus r to the n, all over 1 minus r. And then let's substitute what we have, right? U1 is 5, r is 2, and then Sn is 635. So 635 equals 5, 1 minus 2 to the n, over 1 minus 2. Now, again, we haven't learned how to solve exponentials yet, technically, so we're going to solve as a calculator y1, y2. Now, I can make it a little nicer before I plug that in, though. So I could just plug it in now, y1, y2, done. But this is negative 1, so I'm just going to say that 635 equals negative 5, 1 minus 2n. Like that. And again, if I want, I can make it a little nicer by dividing by -5. But I'm going to leave it like this because, again, I could type this into the calculator. It's fine because that's how we're solving it. So bring up my calculator. I'm going to solve this with the calculator. So we'll go y1 is 635. And then y2 is -5 to the 1 minus 2 to the n, to the x in our case. Now, I'm going to go to my windows. And my resume standard is what we normally have. So that's how I was doing that. I'm not going to be able to see my answer because that's going to be at 635. So let me stop this already. I'm going to go to window. I have to make my y max like 700 so I could see it. Right, so I have to move it all the way up to 700 so I could see it. And again, I might have to move it more left and right to see the intersection, but let's start with this 700 first. Hey, it's right there. I don't have to change anything else. So let's just find an intersection. Again, if I'm doing it with the calculator, I want to see it so you can show me, like, oh, that's where the answer is. That's what you did. You didn't get a magic out of thin air. So show the graph. Intersection. Let's go more that way. That's my first curve. That's my second curve. And we get x equals 7. I guess in our case, n equals 7. So there we go. N equals 7. That was the question, right? Find the sum of the first n terms. Find n. So n equals 7. There we go. That is it.